We're evaluating the aurora by using our MG101 dew point generator to generate a given dew point temperature. And at the same time, we're sampling the output of that generator to our chilled mirror hygrometer system, consisting of a 4-stage chilled mirror and our optical analyzer. Currently, we're generating about minus 61 dew point in degrees C, and the aurora is reading about minus 61 as well. In addition, we're sampling the gas through two industrial trace moisture transmitters that use aluminum oxide, the MMY30 and the DuPro, and those are reading minus 59.6 and minus 64 respectively. One of the benefits of aurora is its ability to quickly respond to process upsets. So we're going to simulate that by introducing some moisture into the aurora system. Wow, you can see how quickly that system wets up. And if we now switch back to the gas that we were generating by just flipping this valve, we can see how quickly the aurora dries down. It's actually still going up. It'll take a while for it to purge the sample line. We have about 6 feet of flexible tubing as the sample line. At the same time, the data is also being logged and graphed on AuroraView software, which is connected to the Aurora by its RS-232 interface. You can see over here that spike representing the increase in the humidity. And already we can see that as we switch back to the dry gas, it's starting to dry down. Now, if you recall, the original setting was about minus 61 dew point, as confirmed by the chilled mirror as well as the other two instruments. So that's still reading minus 61, as well as the other instruments are still reading dry. And the aurora is about now reading about minus 44. This is in real time. Now again, with the aurora, the optics are very fast. You have the capability of responding within 2 seconds. But remember, whenever we introduce moisture into a trace moisture system, everything has to dry out, including the coalescing filter, which you can see in here, the sample tubing, and all of the wetted components. Recall that we also have about 6 feet of flexible hose, and we're coming out of the generator all the way through that hosing, a flexible hose, into the aurora. So already in the time that we've been looking at this, we're back down to about minus 54, and if we wait a bit longer, we certainly will get back to the original reading. So here we have just a graph of the process upset, and you can see that it's spiked up in terms of dew point pretty much off scale, and you can see the green line showing the dew point where it's coming back and then starting to settle out. And that elapsed time is being recorded. We can produce a graph of that as well to prove what the actual response time is. Okay, we're at minus 56, which is about 5 or 4 degrees away from our original point, and the unit is still drying down. Well, it's been about 7 minutes since we originally spiked the aurora and introduced moist air into it. and you can see that it's practically back to the original starting point. It's within a half a degree of the minus 60 target value. The Aurora is extremely fast, and this test has been done in dry nitrogen. So one of the advantages of the Aurora, it's one of the only TDL hygrometers on the market that can also be calibrated and verified in nitrogen. You can use it both in nitrogen as well as there's an internal switch that enables you to apply it to methane or natural gas. Testing also shows that these aluminum oxide sensors are fairly accurate. These are demo units that are used in our sales training classroom here in Boston, and these units are well over a year old, but you can see they still maintain very good accuracy. If we were to exercise these units through various dew points, you would see that they typically match within their original plus or minus 2 specification.